For a lot of students who breezed through middle school, high school math and science is where the illusion of effortless genius finally shatters. The raw intelligence they used to coast on simply cracks under the pressure of advanced calculus and physics. When educators realized that IQ alone couldn't predict who would survive these bottleneck classes, they turned to a psychological concept that promised a universal fix: grit. Coined by psychologist Angela Duckworth, grit is defined as the combination of long-term passion and perseverance. The theory gained massive traction because it worked incredibly well in highly specific, competitive arenas. Researchers found that kids who scored high on grit outlasted their peers to advance further in the National Spelling Bee. It was the same story at West Point. High grit scores reliably predicted which cadets would survive the grueling summer training program and which would drop out. Grit appeared to be the ultimate predictor of human achievement. But when researchers tried to apply that exact same psychological formula to the everyday grind of high school math and science classrooms, a massive flaw emerged in our understanding of how students actually succeed. This diagram shows the architecture of grit. To understand why it failed in the classroom, we have to split the buzzword into its two distinct psychological components. The first pillar is perseverance of effort. This is a person's ability to work strenuously toward a challenge and maintain that effort even when they fail or hit a plateau. The second pillar is consistency of interest, the passion component. This is the ability to maintain deep focus on the exact same goal over years, resisting the urge to switch to new pursuits. Here is where the math stops adding up. When researchers measured both of these pillars against actual high school STEM grades, the passion half completely broke down. A massive study by researchers at the University of Maryland and University of Texas sought to test those grit components against established personality models in high school students. They compared grit to a classic Big Five personality trait known as conscientiousness, which psychologists define as the tendency to be orderly, dependable, and diligent. The researchers wanted to see if the grit literature had fallen into the jangle fallacy. That is a psychological trap where scientists believe two concepts are completely different simply because they have been given different labels. This graphic shows the structural equation models from the study. The data proved that the test items for grit and the test items for conscientiousness heavily overlap. Statistically, they are not unique constructs. By rebranding standard, boring diligence as an exciting, passionate trait called grit, we have been handing overwhelmed students the wrong roadmap for academic survival. The study revealed a stark reality about how students actually get good grades. Consistency of interest, the passion part of grit, turned out to be a notably weak predictor of math and science scores. When you think about it practically, it makes sense. A student does not actually need to harbor a burning, lifelong passion for trigonometry to get an A in the class. This chart visualizes the true dominant predictors of STEM success. You can see conscientiousness and the perseverance of effort component towering over consistency of interest in their impact on GPA. These winning traits are not fueled by fiery inspiration. They represent the unsexy, dependable ability to sit down at a desk and do the hard work even when the equations get incredibly complicated. Success in abstract STEM subjects isn't driven by a magical inner passion. It is strictly a test of pure endurance and dependable routine. For students struggling to keep up, this data is incredibly liberating. Stop stressing about finding your passion and instead focus entirely on building your conscientiousness muscle. This flowchart illustrates the first protocol, deliberate practice. It requires taking on an appropriately challenging math or science problem, getting immediate feedback to spot your errors, making adjustments, and then attempting a harder problem. The second protocol is prioritizing habit over motivation. Commit to a set study schedule so the behavior becomes automatic, completely bypassing the need to feel inspired before you open a textbook. As author James Clear points out, mentally tough people don't rely on sudden bursts of motivation to execute their daily work. They rely on routines. Implementing these two protocols shifts the burden of academic achievement off of innate brilliance or deep passion, placing it squarely onto simple, manageable daily systems. In order to make those daily systems work, we have to travel to Stanford University for the final required mental framework. That framework is the growth mindset, developed by researcher Carol Dweck. It is the scientific understanding that the brain physically changes its structure and capability in direct response to effort and challenge. This mindset completely reframes a failed chemistry or physics test. A bad grade is no longer a permanent reflection of your intelligence, but merely a necessary data point to guide your next study session. Acing high school math and science isn't about being a born genius, and it isn't about having passionate grit. It is the highly trainable, unglamorous power of being conscientious, putting in the reps and trusting the process.